As a school student, I was very much interested in wireless and radio communication. In the school, I had made my own, in those days, what we used to call it as a crystal radio, which could at least catch the Vadodara station, AM, it was, and I could listen to it on my headphones. Then in 1957, I was here in Ferguson College in Pune, and that is the time when, in the second year of the college at that time, the first satellite, Sputnik 1, was launched. And when I was reading about what it really means and what the future would be, there was some discussion in some of the papers about communication satellites coming up afterwards. So I got very much interested in that, and I decided that, okay, this is a new subject which I should study, because that at that time that was a subject which was not taught in the colleges or anywhere. The radio communication also was not taught for the BE electronics and telecommunications, as they were calling it. They are more into the line communication, but not the radio communication. And radio communication as a subject was being taught when you do your masters in physics, with a specialization in radio communication or wireless. When I completed my BSc, that year, in 1960, there was a major competition for writing essays in Vadodara MS University. And the subject was rockets and artificial Earth satellites. So I wrote that essay, and I got the first prize for that essay. So my professor knew my interest at that time. So after BSc, I was looking for applying at various places, whether to continue with the masters in physics, or at that time I had some ideas about starting my own research work also. Dr. N.S. Pandya, he suggested that if you were to start any of the ideas of starting the career right now itself, etc., and if you were to leave that, you will be just only BSc. Because at that time, there was a possibility that I could have applied for this atomic energy training school in Mumbai. I was quite confident that I will get through. He said, but if you decide to leave, then you will be just only BSc. So why don't you go and talk to Dr. Vikram Sarabhai in Ahmedabad? I wrote a letter, I got an appointment, and I talked with him. I thought that he will give me about maybe 5-10 minutes or so. But he spent more than an hour or so talking with me, trying to understand what I wanted to do. And finally, he said that the best thing for you to do would be come to Ahmedabad, join the master's program here. And the university is very close to the physical research laboratory. So rest of the time you start working at the physical research laboratory to get practical experience in electronics, whatever my interest was there. So I accepted that. I immediately came to Ahmedabad. In those days, we had access to all the, what should I say, surplus equipment which was purchased after the Second World War. Excellent quality radio receivers, and how to use the radio receivers in research work. That was the basic work that was going on. Many other students were working on that also. So the task given to me was that how to use that one for receiving the signals from satellites. And that's how the entire thing started. So my interest in this space has been there from 1957 onwards. It's not just only the satellites, astronomy, but basically trying to then use the satellites for certain very specific applications. Just after completion of my MSc, then I was accepted as a student at Physical Research Laboratory. And I didn't know at that time, but a decision was already taken that we were going to go ahead and start our own sounding rockets program. And that was the idea was that the geomagnetic equator goes slightly north of Thiruvananthapuram. So if we could launch a rocket through that area in the upper atmosphere, we could then study the effect of the magnetic field on the atmosphere at, what should I say, the high altitudes. And I was selected as one of the person to join with the team. In 1963, January, we were sent to USA to be there at the Goddard Space Flight Centre in near Washington, D.C., and also to be at the Wallops Island rocket launching station of NASA. And that was a really good exposure, right, at that particular age, to understand about the rockets, how to handle rockets, what happens when a rocket doesn't function properly also. So everything connected with the rockets and satellites. We got a good opportunity, and we were there for just about 6 months or so. Our team consisted of Ramkrishna Rao, Prakash Rao, and myself. We were three from our physical research laboratory. Mr. Aryabhata came and joined with us from atomic energy. Mr. A.G.S. Murthy, he came from I think it was a defense production factory in Ambernath, if I'm not mistaken. Mr. Ishwardas, a mechanical engineer from this the Central Workshop of Atomic Energy establishment. Dr. M.S.V. Rao from the Meteorological Department. And APJ Abdul Kalam. So, I met him for the first time only in March 1963 when he came to USA. And it was really interesting because out of all of us who were there, he was the only aeronautical engineer. And we could discuss various aspects of the rocket flights and other things from that time onwards. And he remained as a good friend since then. After the initial rocket launching was over, which happened in 1963, that was from the Thumba Equatorial rocket launching station. But that was my first experience of looking at a site as to what would be really required if we were to launch a rocket, what kind of a site would be required, etc. And in 1966, I was transferred to Thiruvananthapuram, and we started actually making our own propellants, because propellant technology is something which nobody would share. You could not have taken that easily. But Dr. Sarabhai was able to persuade and get that thing going on, and that is from France we got certain amount of technology transfer for a type of a propellant which they were using. But looking at that propellant, we knew that we could not really use that propellant to make large rockets, and not definitely for a satellite launch vehicle. For smaller rockets, certainly it was possible to use such propellant. So in Thiruvananthapuram, when we set up near this Thumba rocket launching station, we set up the Space Science and Technology Centre. And that is where Dr. Vasant Govarikar was looking at the propellant development, Dr. Muthanayakam was looking at the mechanical engineering, and he later on started looking at the liquid propulsion systems. Vasant Govarikar was looking at the solid propulsion systems also. And so we started the entire work. Dr. Gupta was looking at the control systems. I was looking at the electronics that is required for the rockets as well as for the satellites. And in 1967 end, Dr. Vikram Sarabhai talked with us, because by that time we had launched our first rocket, which we had made. Small one, but and it was really an eye-opener kind of thing, because Dr. Sarabhai started talking with us about launching satellites. And we set up a team. It is Professor Chitnis from Ahmedabad and myself from Thiruvananthapuram. For us to look for a site for launching a satellite, both of us, we knew that yes, we had to launch it from the east coast, because we had to launch it towards east to get the, what should I say, the advantage of launching it and getting the advantage from the earth spinning itself. So we went and talked with Director of Industries in Hyderabad, Dr. Abid Hussain, and he told us what kind of land would be available in Andhra Pradesh. We also looked at what is available in Tamil Nadu also. At that time, we had just the beginning of the Kalpakam atomic power project. And so from Atomic Energy, we got the full support from those people. And then we went and looked at all the basic requirements of the land, for the empty land, basically, what we were looking for. So we were looking for something like around maybe 5,000 acres or so. Our Thumba Equatorial rocket launching station was only 500 acres, but this place which we were looking for with the larger rockets were calculated, and so about 5,000 acres would have been sufficient. But Andhra Pradesh government had offered Sriharikota Island with the Pulikat Lake in the background. And that was about something like maybe 29,000 acres or so. But the question was whether we can really take over the entire place, because already that place was used for what was known in those days as the reserve forest. But it was a very interesting kind of a geography that it was isolated. The island was formed due to the Buckingham Canal and also the backwaters of the Pulikat Lake. So it meant that there won't be any population around, and we would then have no concerns regarding the safety of the population, because whatever we were going to do, if there is an explosion occurs, it should not affect the rest of the people. So that's why that kind of a site which we were looking for. After visiting that island, the island is formed only due to that Pulikat Lake, but otherwise we were able to drive on the lake bed. But they had told us that you have to come back next day before such and such time, before the tide comes in. They were building the road, but the road was not complete at that time. But Buckingham Canal we had to cross only by using a boat. So that's how we started the finding a site. Basic requirement for site selection was that it should be unpopulated area. It should be available as a government land so that acquisition should not become a problem. And whatever private occupation was there, we were going to give them the compensation. But I had to complete the site selection process by studying it completely, looking at where we could put various of these facilities, including making of the propellants. At that time, I had even considered locating a small airstrip, which was possible. It was such a big island, it was definitely possible. But then we had to also take a look at approach to the island from the southern side, which was through Tamil Nadu area. We didn't go too far north of Sriharikota Island, because then it was like maybe 100 kilometers away. From that time onwards, we knew that Air Force was looking at Chilka Lake and that area for testing their own surface-to-air missiles, those missiles-related things. South of Sriharikota Island, south of Chennai, I went to Kalpakam and all the way up to Pondicherry and Chidambaram. I spent, I think, more than 2 months in just going through every location, trying to understand what was available. There was one good location in Tamil Nadu, but it was a delta between, I think, river Kaveri and Kolrun. And it was very good rice plantation. So we would have to really take over that kind of a situation. It was not acceptable at that time. And then we selected Sriharikota Island as the site for our future. Once we selected it, I wrote the complete report. But then we wanted Dr. Sarabhai to see it. And we then arranged for Sarabhai to visit. But the season was such that the water had already come into Pulikat Lake, and we would have to cross it using boats and all other facilities. So a plane was hired from Hindu. Hindu as a newspaper, they had a Dakota plane which they were using for transporting in those days the newspapers which were printed from there to Madurai and Thiruvananthapuram and other places. So that plane was hired, and then we went in that plane. Dr. Sarabhai was there, Mr. A.G.S. Murthy was there, Y.J. Rao was there, minister from Tamil Nadu government. This was in 1968. Mr. Narendran, he was also there, collector of both the districts there and also Mahabalipuram. And then we went over that. Once the plane took off from Chennai, then the co-pilot got up from his place and he came inside the cabin. Dr. Sarabhai went and sat in that chair. And I was standing between the two, the pilot and Dr. Sarabhai, and showing them whatever I had seen on the ground and how we came to the conclusion finally. But obviously, at that time, knowing that Tamil Nadu government people were there, I didn't say why. I said both of them and comparison of every single whatever was going on. Later on, Dr. Sarabhai went and saw that particular place when the water was out from that area. And after finishing that work, then Dr. Sarabhai announced that, okay, now your work has to change. Change was to join with the group which was coming up, being established at that time. That was the National Study Group on Satellite Communications. What had happened was that in 1967, NASA had proposed that they were going to have a series of satellites called as Applications Technology Satellites. And for now that satellite, Applications Technology Satellite F, was to have a very large antenna on the satellite. We had set up our experimental satellite communication earth station in Ahmedabad in 1965. The work had started, but then 1967 it became operational. And at that time, Dr. Sarabhai's idea was that, okay, we are going to set up this as an experimental station, which will also provide training facilities for our Indian people as well as people coming from developing nations. And once we were discussing those kinds of future plans, the idea that NASA had come up at that time was that this new satellite that they were going to launch was going to have a very large antenna on the satellite, 30 feet diameter antenna on the satellite, and a high power transmitter. That would really then mean that we could receive the signals from that satellite, our TV signals particularly, and bring television to India. So, in those time, there was only one television station operating in India, that was in Delhi, and that it was an experimental station. In order to bring television throughout the country, would have required a network, that is microwave communications network, which would then connect all the stations together for a national network, and multiple number of television transmitters would have been required. To have that kind of a investment, it was considered that it may not be possible. But Dr. Sarabhai looked at it in a slightly different fashion. He said, okay, in that case, why don't we use the high power transmitters on the satellites and bring the television signal throughout the country using satellite communications. So 1967, the studies had started as to how one can use the NASA satellite as a starting point. And then obviously, we'd have to follow it up with an operational system. So 1968, September, October time period, I was told that, okay, I have to change from these rockets or whatever else I was doing and get into the satellite communication related area. My task at that time was to understand what kind of experiment we were planning. That was the satellite instructional television experiment we were planning, and take it further after the experiment was over to go to the operational system. So 1969, then we started the initial work, and then 69 March I was sent to Goddard Space Flight Centre, and then we conducted our studies with General Electric on one side and UJS aircraft on the other side. what kind of a satellite we would require. Later on, then we conducted one additional study that was in 1970, which was with MIT, because the MIT was also involved in defense communication satellites and operational systems. And that's how I got into the satellite communications area. We had three major applications in those days that we were looking at. The first one obviously was meteorological Earth observations. Second one was the satellite communications, because meteorological satellites, they were in the 1,000-kilometer kind of orbit, while communication satellites, we would have to go up to 36,000 kilometers orbit. And the third discipline that was coming in at that time was looking at the Earth for the Earth resources. Anything connected with agriculture, connected with mining, connected with minerals, urban development. And so remote sensing was the third discipline that was coming up. Later on, we got into navigation, geodesy, so many other applications started coming up. The important thing has always been that when we look back, one of the first papers on the subject of satellite communications was written by Arthur Clarke in 1945. Even before any kind of a large rocket was developed. At the time, the largest rocket was German rocket V2, which was developed and which was used extensively by them. But Arthur Clarke had predicted that yes, there is an orbit like this, 36,000 kilometers away, and it should be possible for us to use that for intercontinental transfer of television signals. Across the sea also we could go. Because microwave communication required every 40 kilometers to 50 kilometers to have a repeater station. Even the undersea cables also required repeaters. So undersea cables were there for the telegraph as well as for the telephone communication. But 1945, he had that foresight and he had predicted that it will happen, that people will be able to receive the television signals in their homes using a 1 meter diameter antenna. So that is how everybody was really fired up with that idea that yes, it is definitely possible. And that's how we got into this our INSAT satellites. I was the first project director for this our Indian National Satellite for television, telecommunications and meteorological Earth observations. We had also studied the remote sensing, and I got involved in the initial studies for the remote sensing, and then our Indian remote sensing satellites. And meteorology was part of the INSAT satellite. So that's how applications are really very, very important, because finally, whatever we are doing should result in somehow improving the life of our general population, economic development. And we had the first major opportunity that which we got was in 1975. We conducted the satellite instructional television experiment. Now this year we'll be completing 50 years since we did that work. And it has been really a satisfying work. I had met Professor Satish Dhawan in 1965. I had gone from Ahmedabad to Thiruvananthapuram for arranging some of our rocket flights, and I knew that I was going to be transferred to Thiruvananthapuram in 1966. So 1965, there was a meeting of the Indian National Committee for Space Research. Like Mr. Satish Dhawan, as a member, he was there in Thiruvananthapuram. And I talked with him for about an hour and a half. And we discussed all kinds of things. At that time, I didn't know what the future would be, but in 1972, when I met him again, at the time he had become now the chairman, ISRO. He looked at me and he said, "Haven't we met earlier?" I said, "Yes, in 1965 we met." After that first time, because he continued as the director of the Indian Institute of Science in Bangalore. And 1972, then he talked with me for some time, and then he said, "Now time has come. You have to start taking full responsibility for these satellites and other things." I said, "Yes, certainly." since you had asked about Professor Dhawan, let me just tell you, we had a very interesting conference in the Space Application Centre. The conference was about the design philosophy and design engineering, and from Mumbai IIT, people had come there, faculty, for talking about the design and other aspects. So at that time, I had asked Professor Satish Dhawan a very interesting question, which was there in my mind as to how things really look to us. Our television tower in Mumbai at Warari, that's about 1100 feet tall. Eiffel Tower is just about 680 feet or so. But Eiffel Tower looks far more beautiful, elegant kind of. So I'd asked a question as to what kind of tools Eiffel would have used, what kind of theory that he would have used to design such a structure in 1800 and something like 60, somewhere around that time period. No computers available. So that, what was the design philosophy? How did he design this structure? Why does it look so elegant? So I said there are two things. Number one, it's a very much, what should I say, over-designed, factor of safety being very, very high. And second thing is, he said it's a very simple thing that in the first or second year of this applied mechanics in the engineering course, they talk about this, a long chain is hanging from the roof, etc., etc. So it is that same quaternary curve is the one that has been used by Eiffel. So that is the one that is you have to have that elegance, the simplicity, but the equation is very, very complex. Yeah. In the history, one of the important events that had occurred was that in USA, the first atomic reactor was built by Enrico Fermi. And in 1945, the atomic bomb was also exploded over Japan. That was the time period in which Dr. Bhabha wrote a letter to J.R.D. Tata, saying that this is one area in which we should be focusing, and that focus should be on the use of atomic energy for power production. Because energy, everybody knew, right, from the very beginning, is going to become very, very important aspect. After independence, J.R.D. Tata, that is, just at the time, even before independence, J.R.D. Tata had gone ahead with it, and the Tata Institute of Fundamental Research was established in Mumbai with Dr. Bhabha being there. And later on, after the independence, Prime Minister Nehru had fully supported this idea that atomic energy should be used for power production. Dr. Vikram Sarabhai, Dr. Bhabha, they were both working at the Indian Institute of Science in Bangalore with Sir C.V. Raman being there. Dr. Vikram Sarabhai, after the war was over, came back to Ahmedabad, and I think he finished then his PhD also, and he decided that an institute which is, what should I say, devoted to research work should be really started in Ahmedabad. And the first thing that he was able to convince all the other people there was to start the Ahmedabad Textile Industries Research Association. So Atira was the first one to be started. Dr. Sarabhai was continuing some of his experiments in his residence in Shahibag area. And he was able to convince later on Ahmedabad Education Society, Kasturvi Lalbhai and other people to start the Physical Research Laboratory. So Physical Research Laboratory was started in Ahmedabad, and in 1948, the person who had just retired at that time, Dr. K.R. Ramanathan, he came and joined with Dr. Sarabhai. Now, Dr. Ramanathan is credited to have actually observed Raman effect. If you look at back in the papers, observation was actually done by the students. Raman gave the full theory behind it. The actual observation was done by Ramanathan. And then later on, Ramanathan went and joined with the India Meteorological Department. But in 1948, after retirement from there, he came and joined with Physical Research Laboratory. Shanti Swarup Bhatnagar was given the responsibility by Pandit Jawaharlal Nehru in starting the Council for Scientific and Industrial Research, CSIR. And a large number of laboratories were set up by Bhatnagar. This National Physical Laboratory in Delhi, National Chemical Laboratory here in Pune, or forget now. There are certain other names will come to me. Central Food Research and Technology Industry, CFTRI in Mysore. Like all these, about 40 different laboratories were set up. But the real issue that really came up later on, and which we realized at that time, only looking at history, because I was very young at that time, but there was no focus. In CSIR related things, there was no focus. The focus was there in atomic energy because it was very clear that what we were going to do is to develop the power reactors, and that's how, even as early as 1953, 1954, I think our first reactor, Apsara, became operational. Vikram Sarabhai had taken the lead in this physical research related things, and he was looking at cosmic rays, and Ramanathan was looking at the upper atmosphere. So 1957, that was the International Geophysical Year, where the activity on the sun was to become the maximum. So that research work was going on, and Dr. Sarabhai then took the lead from that one to get into the space-related things. Dr. Bhagwantam was given the responsibility to be there as the scientific advisor for the Defense Ministry, and all the defense-related laboratories came up at that time. The idea of CSIR was that, okay, they would develop the technology and transfer it to the industry and make, indigenization completely possible. But their efforts were not really, in the initial period, not so good. In order to be able to transfer the technology to the industry, they were just going ahead with certain things, with some of the technologies were not at all fully developed. They had not fully understood the technology transfer concept. Looking back, I really remember that we had one conference in Delhi. It happened. I was there at the time. Professor Menon, chairman of the Electronics Commission, was there. Dr. A.S. Rao, he was earlier the head of the Electronics Division in Mumbai at Atomic Energy, and then later on became the chairman and managing director of this Electronics ECTV and Electronics Corporation of India Limited. He was invited and I was invited because we were successful having done the technology transfer. Because I transferred the technology, whatever we developed in Ahmedabad, and got 2400 those antennas developed and 2400 microwave receivers also for the satellite instructional television experiment. So, and people were asking us questions. So when Dr. A.S. Rao was asked a question as to how he was successful in transferring technology of this atomic energy, electronics related things to Hyderabad, he said, it's not just only technology that was transferred, I transferred people. And one of the important things has always been in my mind also the same kind of a thing, that when there was a production line being set up in Hyderabad for this our satellite receivers, it was clear that the people who were there, they were good people, but they would not really know everything inside the satellite receiver related things. So I had sent 6 people from Ahmedabad to sit there in Hyderabad and do the initial work on the production line itself. And that's how we had to actually do so. CSIR technology transfer also earned initially some bad name because many of the scientists were claiming too much of royalty also. Well, in atomic energy and space related things, the initial discussions were there. So Professor Menon, as the interim chairman, when he had talked with us, he said he is going to follow the philosophy of TIFR. Whatever is the money that comes as royalty will go to the staff welfare fund. It will not go to any individual scientist. And that was one of the problems of the CSIR. Some of the individual scientists were getting royalty for the things which they had developed. So they had developed it using government facilities. They were getting the salaries. So that's the philosophy with which things started. The real successful story came later slightly when Dr. Swaminathan took charge of this, our Indian Agricultural Research Institute. So agricultural things, when we look back as to how things happen, no? Using the same concept of the science and technology related things, if we were to look at it, the development of the Kheda district, that milk federation, Amul. So that was definitely possible only because of the scientific outlook with which Kurian had started this entire work. And not just only we are looking at the milk production, etc., but improvement of the feeding of the animals. Till that time, he discussed with us various things. Because we had asked a simple question that in 1973-74, when Kurian had come to Ahmedabad, in Maharashtra, sugar cooperatives succeeded. In UP, they did not. In Gujarat, milk-related things succeeded. But the same thing did not happen for groundnuts. What exactly were we missing? Why they didn't get into this kind of a cooperative situation? So Kurian talked with us about not having the complete picture with those people. Somebody has to be there to take a lead and take it up further. Time was that I was in charge of the establishment of the television transmitter near Nadiad. There is a village called as Peej. So there we were going to produce, Ahmedabad we were producing the television programs, but they would be broadcast from there. And receiving area would be Anand and that entire area. So we were looking at this as part of the satellite instructional television experiment. What to really bring it out? Because this was a Gujarati production which we had to do from Ahmedabad. So Amul was going to sponsor certain number of television sets. Certain number of television sets were to be sponsored by Gujarat government. And so that's how we started talking with him. So finally we had to communicate with people. What are we going to communicate? Development of agriculture, development of the cooperatives, milk related things, health. So that entire perspective changed after 1965 particularly. Because 1965 war with Pakistan indicated as to what we actually needed to improve in electronics. And Dr. Bhabha was involved in the writing of the Bhabha committee report afterwards. But he passed away very early. And then Dr. Sarabhai completed the report. And then that's how electronics department, electronics commission came into the picture. But the science, that is reliance on science and technology, because Nehru was very clear as to his vision. That certain things have to be done for agriculture, certain things have to be done for the industry. But we suffered from one particular problem in the entire industrialization. Right from the very beginning, people were looking at industry as a group that exploits others. While if you want to have proper industrialization, proper management of resources, then you should have definitely prudent financial management. Making profit is not really bad. If you don't make the profit, you are not going to survive that industry. That's what happened to textile industries in Ahmedabad, in Mumbai. At one time, Ahmedabad had more textile mills than any other place in the country.
Manchester.
Yeah. So Ahmedabad, Kanpur and Mumbai. These were the real centers for textile industry. But as the industry changed, the industry, instead of, what should I say, the completely integrated, right from cotton to the final product, everybody started looking at multiple locations and multiple processes. So each one became a process specialist to do the work. Yeah. We used to interact with certain people from NASA, certain people from European Space Agency. We had Professor Itokawa. He came from Japan. Professor Blamont came from the French CNES. We were definitely interacting in the initial period because Dr. Sarabhai had asked Professor Blamont and Professor Itokawa. And Itokawa was there with us for almost 3 to 4 months in Thiruvananthapuram. We used to discuss all kinds of things. In 1966, I was transferred from Ahmedabad to Thiruvananthapuram. And at that time, I came to know about this setting up of the Indian Institute of Management in Ahmedabad. I was interested in management as a subject. I was already going ahead with my physics, mathematics, and other things. So I decided to do the full-fledged self-study of. I said, if nothing else, I can get the names of the textbooks, whatever they are using, I will go through the text myself. And I got very much interested in economics by Paul Samuelson. That was the textbook that was being used. And started reading more about economics. And later on, when this proposal for the satellite instructional television experiment came, or at that time, we had to also study and show how INSAT is going to be self-sustaining kind of a situation. We had to do the full-fledged calculation. And whenever we did the calculation and presented, Dr. Sarabhai would start asking us all kinds of questions, including the interest rates and depreciation and allocation of funds, etc. So we really studied at that time. So if you study properly, other subjects also. So that's the way it really helps. And later on, after my retirement, when I had started with work with some industry here, so I had told those people for the finance related things, I said that I can read the books that you are reading and studying and work on various things, but you cannot read my technical books here in the physics. So one has to take full interest in these particulars all around. NASA is no longer developing smaller launch vehicles. They are developing much larger one, that is for the Artemis, to be able to go there and land on the moon or land on the Mars and then come back. So that those type of launch vehicles, they are now looking at it. European Space Agency had a very bad period in between. They stopped the Ariane 5 and Ariane 6 was delayed. China also the same kind of thing. In the last 3 years, Russia has fallen behind because of the war with Ukraine, if I look at it that way. SpaceX, Blue Origin, their plans are not necessarily only for the science-related things now. They're looking at space tourism also, which is going to be good. So, something very interesting concepts are coming up in the space tourism-related things. Maintenance of the International Space Station. Similar situation we are also going to get when the multiple number of agencies, multiple number of industries start developing a launch vehicle. Once you start a launch vehicle program, unless you have got a specific production run, you cannot sustain it. In order to be able to sustain it, we will require certain minimum number of launch vehicles, even any industry which wants to take it up. So at least with the PSLV now, they are starting totally privately funded private in the industry. Only thing what is happening is that they are still not investing enough in the testing facilities. They will have to be still dependent upon the testing facilities of ISRO, which means again, when you look at the numbers, it looks more like a bottleneck. SpaceX has gone ahead with their own testing facilities. Blue Origin is basically supported by Boeing. So they are having good enough test facilities. In USA, all this development has taken place because the government also went ahead and established large number of testing facilities, not just only in one location, but in multiple locations in multiple industries. That is something which we really need to do in terms of testing facilities. And then only I think we can see further things coming up. How long this will be sustained, everything depends upon finally the revenue stream. The economics has to finally work it out. Only then such a thing can be sustained.
Even the budget allocation.
That's right. Whether in private industry or government, finally somewhere somebody has to pay the money and get the things done, isn't it? And they have to earn the money.